Chef, infrastructure automation as Ruby code. Agenda, configuration management models, Chef history, why Chef, convergence lifecycle, getting started, basic workflow, cookbooks and recipes. Configuration management. Configuration management describes and enforces the desired setup of servers in code, so their state stays predictable and repeatable over time. If a server drifts from its intended configuration, a configuration management run can bring it back in line automatically. Almost every team running more than a handful of servers relies on some form of configuration management. Any team managing infrastructure at scale needs a repeatable, testable way to configure it. Manually configuring each server by hand doesn't scale and gets worse the more servers you add. Push-based and pull-based config management. A push-based tool connects out to each target machine and applies configuration on demand, typically over SSH. Chef instead has each node pull its own configuration periodically, checking in with a central Chef server and converging itself. Push-based Ansible connects out over SSH, runs when triggered. Pull-based Chef client checks in, runs on its own schedule. Problems with push-only config management. Single point of failure. If the machine running the push can't reach a target, the target simply doesn't get configured. Configuration only happens when someone or a pipeline remembers to trigger a push. Newly launched servers stay unconfigured until a push explicitly targets them. Harder to guarantee every node reconverges on a regular, predictable schedule. Scaling a push-based run to thousands of nodes can strain the machine doing the pushing, misses out on the self-healing property of nodes that continuously pull and enforce their own state. The Chef system infrastructure is described in Ruby-based recipes, grouped into cookbooks, and kept in a source or Git repository. A central Chef server stores cookbooks, node data, and policy, acting as the source of truth for the fleet. Chef client runs on each node, periodically pulling its cookbooks from the server and converging the node to match them. Other similar configuration management systems: Puppet, Ansible, SaltStack. Chef advantages: recipes are written in Ruby, giving full programming language power for complex logic. Pool-based governance means every node keeps enforcing its own state on a predictable schedule. A central safe server gives one place to see and manage configuration across the entire fleet. Test Kitchen lets cookbooks be tested against real virtual machines before ever touching production. Custom resources let teams build their own reusable, higher level abstractions. Decades of enterprise adoption have produced a mature ecosystem of community cookbooks. Everything is a resource, almost. One huge benefit is that in Chef, almost every piece of Node's configuration is described as a resource. A resource declares a desired end state, a package installed, a file present, a service running, not the steps to get there. Chef compares each resource's desired state against the node's actual state and only changes what's different. Custom resources let teams package common patterns into their own reusable building blocks. Because everything shares the same resource model, recipes stay readable even as they grow more complex. Cookbooks and recipes. Cookbook, a package of recipes, files, and templates for one piece of infrastructure. Recipe, a Ruby file declaring the resources needed to configure something. Recipe.rb, a recipe declares the resources needed to install and run a web server. Custom resource, a custom resource packages a common pattern into a single reusable building block. History, created by Adam Jacob and released by Oxcode in 2009, building on ideas from earlier configuration tools like Puppet, adopted Ruby as its configuration language, giving recipes the full expressiveness of a general-purpose language. Oxcode was renamed Chef Software in 2013, reflecting the product's growing prominence. Chef later open-sourced its core products entirely in 2019, moving to a fully open-source model. Acquired by Progress Software in 2020, which continues to develop and support the platform today. Why Chef Expressive? Recipes are real Ruby code, capable of arbitrary logic when needed. Self-healing. Pull-based conversions keeps nodes enforcing their own state. Testable. Test Kitchen validated cookbooks against real infrastructure before production. Centralized. A chef server gives one place to manage configuration across a fleet. Mature. Over a decade of enterprise use and a large ecosystem of community cookbooks. Flexible. Custom resources let teams build their own reusable abstraction. The chef server and node object. The chef server stores every node's current state as a searchable node object. Node objects capture attributes, run history, and which cookbooks apply to that node. Knife, Chef's command line tool, queries and manages nodes, cookbooks, and roles on the server. Never hand edit a node's state directly on the server. Change the recipes and let conversions applied. Chef conversions lifecycle. Chef client checks in, pull, build resource list, compile, apply changes, converge, send run data, report. Chef client pulls its cookbooks, compiles the resources they declare, converges the node to match them, and reports the results back to the server. Getting started with Chef. This leads us to the three commands that get a cookbook running. Chef generate cookbook creates a new cookbooks folder structure. Chef client pull cookbooks and apply them to the local node. Kitchen test Run a cookbook against a real test instance. Basic workflow, author, a recipe, maintain, optimize, practice, pull-based workflow. Converging testing and reporting. Some call converge, test, and report chef's everyday loop. Every chef client run compares the note's actual state against its recipes and only changes what's different. Test Kitchen spins up real instances to validate a cookbook before it ever reaches production. Convergence runs on a schedule, so drift gets corrected automatically between deployments. Run reports show exactly what changed or didn't on every single convergence. Supports many workflows, server provisioning, compliance enforcement, ongoing drift correction. Works the same across on-prem servers, cloud instances, and containers. Any questions? Thank you.